Hello everyone, this is a new lesson in mechanics book, page 68. It is talking about tackling mechanics problems. First we need to recall these rules. The equation of motions, we took it before, S equals U plus AT, the V equals U plus AT, S equals UT plus half AT squared, S equals half U plus V times T, V squared equals U squared plus 2AS. And also Newton's second law, which says that F equals ma. We took this before. And then let's go direct to the exercise 4b, page 69. In this exercise we will relate this equation of motion with the Newton's second law. We'll use both of them in some situations. The first problem, it says that a man pushes a car of mass 400 kilogram. So M equals 400 kilogram on level ground with a force of 200 Newton. The car is initially at rest, means the U, the initial velocity equals 0, and the man maintains his force until the car reaches a speed of 5, means V, the final velocity is 5 meters per second. Ignoring any resistance force, find the acceleration of the car. We need to get the acceleration. The Newton's second law includes the acceleration, F equals ma. The force is 200 Newton and the mass of the car is 400 kilogram. So we can get the acceleration will be 200 over 400, which is half meter per second square. Second part of the question, the distance the car travels while the man is pushing. We can use this law, the last one here. V squared equals U squared plus 2S. The V squared final velocity, the U, the initial velocity, and the A acceleration, S is the distance. He said that until he reaches a velocity of 5, so it will be 25, 5 squared. And U is already, he started it from rest, so it is 0. 2 is a constant. A, half, we got it from here. S, we can get S. Half times 2 equals 1, so S equals 25. Means the distance he can travel until he reaches the velocity of 25 is, the velocity of, 5 is 25 meters. The second question is saying that the engine of a car of mass 1.2 tons. 1.2 tons mean 1.2 times 1000. Can produce a driving force of 2000 Newton, means F equals 2000 Newton. Ignoring any resistance force, find the car's resulting acceleration. We need to get the acceleration. Okay. Also F equals ma. The force is 2000 and the m is 1.2 tons times 1000 in kilogram, to get it in kilogram. And we can get the A equals 2000 over this, so it will be 5 over 3, which is 1.67. Second part of the question, the time taken for the car to go from rest to 27, means U equals 0 and V equals 27. So we need to use this equation, V equals U plus AT, the first one, up. The final velocity 25, the initial velocity 0, plus the acceleration 1.67. So we can get the time. The time is 27 over 1.67, which is 16.2 seconds. Question number 3. A top spinner of mass 65 kilogram starting from rest reaches a speed of 10 meters in 2 seconds. Calculate the force required to produce this acceleration, assuming it is uniform, means it's a steady acceleration. So here the acceleration is the difference in velocity over distance of time. He changed the velocity from 0 to 10, so it's 10 minus 0, within 2 seconds. So its acceleration will be 5 meters per second. And then we can use F equals ma using second law. The mass is 65 kilograms times the acceleration, which is 5. So the force required is 325 Newton. First part of the question. Second part, compare this to the force exerted by a weightlifter holding a mass of 100 kg above the ground. The weight equals mg. If he holds 180 kilograms times the gravity, which is 10, so the force needed is 1800 Newton. So it is less than 300, it is greater than 325. This is the first three questions. Question number 4. An ice skater of mass 65, m65, is initially moving with a speed 2 meter, means u equals 2, and glides to a halt. Halt means to stop, means the v equals 0, velocity equals 0, the final velocity, over a distance of 10 meter, means s equals 10 meter. Calculate the size of the resistance force, means the force. First, we have to get the acceleration from this equation. If you use this equation, it relates the v and u and the a and s, so we can get the acceleration. So the acceleration will be 1/5. The negative means it is deceleration, because he started with velocity 2 and go to 0, so it is a deceleration. And then to get the force, F equals ma by means of the acceleration 1/5 and the mass, so we can get the acceleration, which is 13 Newton. Second part of the question, the distance he would travel gliding to rest from an initial speed of 6. Means if you have the initial speed 6 and he goes to from rest to initial speed of 6, we need to get the distance with the same acceleration, which is 1/5. V square equals u square plus 2as. Substitute the v by 6 squared, u by 0, and the same acceleration, so you can get the s. This s is required. So the s equals 36 times 5/2, which is 90 meters. Last part, the force he would need to apply to maintain the steady speed of 10. I think it's the same force, which is 13 Newton. This is question number 4, and your project will be number 5. Thank you.